Alright, let's look at an example of an axiomatic proof. Alright, so here's the axiomatic system. Undefined terms are aba and daba, so some made up words. And A1, every aba is a collection of at least two dabas. Axiom 2, there exist at least two dabas. Axiom 3, if D and D prime are two dabas, then there exists one and only one. So there exists exactly one aba containing both D and D prime. Axiom 4, if A is an aba and there exists a daba D, not in A. Alright, axiom 5, if A is an aba and D is a daba not in A, then there exists exactly one aba containing D and not containing any daba in A. Alright, so what we want to do is we want to prove the following statement. There exist at least 4 distinct dabas. Alright, so let's prove that. Alright, so here's the proof. Alright, so let's write conclusions and justifications. I'm going to give a little bit more room, justifications. Alright, number 1. Alright, what do we know? We know that there exists at least two dabas by A2, so justification would be A2. Alright, and it says that there exist at least two dabas. Right, so we have to find 4 distinct dabas, but we at least found 2. So we know that there exists. So this is a short notation for there exists. 2 distinct dabas. Let's call it D1 and D2, right, by axiom 2. Right, then if you have two dabas, D1 and D2, then there's got to be exactly one aba containing both. So number 2, we know that there exists a unique aba. So I'm going to put aba, unique. So this exclamation mark is short for unique. Aba, let's call it the A1, right, containing, let's see, maybe containing, I'm going to try to use the set notation. Alright, so D1 and D2 is contained in A1, so D1, maybe to do this, D2 is a subset of A1. Right, how about that? So this comes from A3. Right, so right there. So we have two dabas, and you have one aba, A1, containing both. Right, then we can find another daba, because it says that if A4 says if A is an aba, then there exists a daba D not in A. So according to A4, so 3, right, there exists a daba. I'm gonna call it D3, right, such that, right, not in A1. So D3 is not in A1, right? So by looking at, so D1 and D2 are in A1, D3 are not in A1, which means that the D3 is definitely distinct from D1 and D2. So maybe I should write that. So line 4, we know that the D3 is not the same as D1 and D2, right? So this is just a combining line 2 and line 3, right? Just to make sure that this is actually the third daba. All right, so we have a third one. We just have to find one more. All right, so number 5. All right, and we say there exists. Actually, let's see. If A is an ABA, D is a DABA not in A. So like D3 is not in A1, then there exists one and only one ABA containing D and not containing any ABA in A. So there's going to be another ABA. So ABA, actually it's going to be a unique one, right? Unique ABA. Let's call it A2, right? Such that, right, A2 contains D3. So D3 is contained in A2. And A2 has no common element with A1. So I'm going to write it as A1 and A2 are disjoint. So this is a notation. The intersection of A1 and A2 is an empty set, right? So this comes from, let's see, A5. So justification is A5, right? Then number 6, now we know that there's a fourth one. There exists a DABA. D4 in this ABA A2, because there exists, let's see, every ABA is a collection of at least 2 DABAs. So A1 guarantees that since D3 is in A2, but we know that A1 guarantees another DABA inside A2, so we know that there's another one. So this is D4 is definitely different from D3. All right. Then since the D4 is in A2, which is disjoint from A1, and the D1 and D2 is in A1, so D4 is different from D1 and D2 as well. So number 5. We know that the D4 is distinct from D1, D2, and D3. Right, so this is from, let's see, number 5. So let's see, we know that, let's see, maybe combining line number 2, and it tells you that D1, D2 is in A1, and A2 is distinct from A1, so line 5, and also line 6 combined. All right, then we're done. Actually, I'm numbering incorrectly. So let's see. I'm gonna. So this is gonna be. This was 7. Let's see. I'm gonna just erase this, and this is 7, and the last line 8. Therefore, there exists at least 4 DABAs, namely D1, D2, D3, and D4 in the system. So I'm let's see, I'm combining exists, let's see, line 3 tells you the existence of D1 and the D2. Actually, sorry, line number 1. And line number 3 tells you the existence of D3. And then we have line 6 tells you the existence of a fourth DABA. Right. So so that will prove that there exists at least 4 DABAs in this axiomatic system. Right? That's it. I hope that this was clear.